Okay, we are about ready to get started. Sorry for the little bit of delay here, but we have like 15 schools involved with this program this morning, and we wanted to make sure that everyone was connected. And just a reminder to everyone, please keep your microphones on mute throughout the program unless we call upon your site. We have a number of schools here, and if your microphone is unmuted, then our monitors switch back and forth to the schools with the microphones that are unmuted, and as a result, you lose our site here at WVIZ. So again, I want to welcome everyone to our program. We have a very exciting program this morning, something in a sense new and innovative with regards to manufacturing. We're no longer talking about the old dirty foundries. We're talking about plastics. We're talking about additives. We're talking about the new direction of manufacturing and tremendous opportunities for you kids as you decide upon careers, whether it be actually in engineering, some other area of manufacturing, getting involved in the marketing of a product, and so on and so forth. So again, I want to welcome everyone. We're going to give you opportunities to ask questions. We do have a limited number of schools that will be asking questions, but if some of the schools do not show up as indicated here, we'll pick somebody else up. And that's only because we just don't have the time to run through all the schools and take questions from everyone. Those of you who will not be asking questions this first session, you're coming back at our 10 o'clock session, and you'll be able to ask all the questions you'd like at that particular time. So please have patience with us as we move through our program today. What I would like to do now is introduce you to our two guests, two young people actually, who have found their way into manufacturing. Let me just get this all preset here. We had it preset and then I moved everything around and didn't come back to the preset. So we have two individuals with us today who are going to talk in great detail about the changes in manufacturing and a focus on 3D printing. First of all, we have Dana Foster. Dana is responsible for marketing at Togus and his family of companies described as innovation conveyor belt that can help companies from ideation all the way through production. And Togus is actually located in Avon Lake, Ohio, here in Northeast Ohio. And Dana joined Togus back in 2011 and has created the marketing department. She's actually a graduate from Ohio University here in Ohio, graduated in 2011. And we're going to talk a little bit more about her background as we move through the program. Also with us today, we have Anthony Mott, and if I can find his, I had it right here, and then I moved it. Okay, here we go. Put you at the bottom of the pile, Anthony. I'm sorry about that. Anthony is a design and application engineer at Rapid Prototype and Manufacturing, which is RP plus M. And they're also located in Avon Lake, Ohio. Actually, both companies are basically in the same buildings, okay? And Anthony is highly involved in multiple aspects of the business, including customer interaction, production, research and development, as well as the delivery of custom solutions to clients. Since joining RP plus M, he's become involved in this new 3D printed materials and is involved with a variety of different responsibilities, including a high school design contest that we hope we'll have time to talk to you about as we come near our program. Anthony graduated from Penn State, is it Barron? Is that what?
Barron.
Barron in Erie, Pennsylvania, with a degree in plastics engineering and the medical plastics certificate. And joined Togus in 2011 and actually interned at RP plus M in 2012 and has been with them since that time, since his internship concluded. So Dana and Anthony, welcome so much to our program. I really appreciate you being here this morning. Dana, just a little bit about yourself in some general terms. You're in did you graduate from Miami with a marketing degree?
Yes, I actually graduated from Miami University with a communications degree. I wasn't sure what I wanted to go into, and then after my internship, realized that at RP plus M and Togus, realized that marketing was my niche, and I wanted to further pursue career opportunities in marketing.
Okay, and you've been at Togus now just for a couple of years?
Yeah, I've been at Togus in RP plus M for 4 years. I started off in 2010 as an intern, creating the marketing department. And at the same time, we were spinning off RP&M as a company off of Togus. And I've been there ever since.
Okay, very good. Well, thank you for joining us this morning.
Thank you.
Anthony, you are a plastics engineering?
That's correct, yeah.
What led you to an engineering career to begin with?
So I always knew I wanted to go into something engineering. I did well on the physics, calculus, the chemistry, and I knew the engineering was the path I wanted to go down to. I happened to kind of stumble upon plastics whenever my brother actually went to Penn State Barron, and I visited the campus. I researched their engineering programs. I saw that plastics engineering had 100% job placement, and that was enough for me to at least give it a try. And I got really lucky that I enjoyed it a lot, and I'm still enjoying it now.
Okay, now both of you had internships with the company.
Yep.
Okay, and what actually is the internship, and what kind of doors does it open for you?
So my internship was a little bit different because no one else had been in the marketing department. So I was working closely with the president of the company and understanding pretty much, how our company works, what do we do, who are our customers, understanding from start to, when we ship products out the door. So I was able to understand each department within our company. And I was there for 3 months and then worked from school full-time while I was in my senior year at Miami.
And it was a paid internship?
Paid internship, yep.
Okay. And Anthony, how about you and the internship?
Mine initially started off with Togus, and it was a co-op position. So it was a 6-month co-op. And whenever I talk about the co-op programs anywhere, I strongly advise it just because it gets you the longer term experience, gets you there a few extra months so you can be more of an impact for the company. And I really enjoyed my time. And then they invited me back the summer after for my 3-month summer internship, which was great as well.
And then that also led to a permanent position with the company?
Correct, yeah.
Okay. Do most internships lead to positions with the companies? It sounds like it.
Yeah. I mean, you get to know people within the company, you get to know, what the company does, and they invest in training and guiding you into your career. So a lot of the times, companies, if there's an open position, they will hire you on full time, depending on the experience and if you're a fit for the company, if the company's a fit for you.
Okay. Now, let's talk a little bit about additive manufacturing, prototype manufacturing, and Dana, you're going to kick us off with that?
Yeah, so we're here to talk to you guys about 3D printing. It's the new technology that's out there. There's a real hype out there for it. 3D printing's creating a new way of manufacturing things. So we have a variety of different parts up here. And this is what we're doing at our company. So to give you guys a little bit of a background, Togus is a plastic injection molding company. So we're manufacturing thousands to millions of parts per year for customers within the consumer products, healthcare, and household appliances. And we invested in the 3D printing machines and realized there was a high demand for 3D printing. Customers were coming to us all the time, and we realized that it could be its own entity. So RP&M was born from Togus and is now a sister company, its own entity, and provides the 3D printing services and engineering services for our clients. So in traditional ways of manufacturing, you have to cut a steel mold and then put the mold into an injection molding press, and that's how you start up any program. Well, with the 3D printing, you can create a CAD model, send the CAD model to the 3D printers, and then within a couple of hours have that part within hand. So, for example, a household appliance customer of ours on Togus asked us to 3D print their part before going into production, and this reduces costs and product development cycle times, meaning they can see their part within a couple of hours, touch and feel it, make sure it fits, it's the right design before going into the mass production side of cutting a $50,000 steel tool and then waiting 8 to 10 weeks to get that tool in hand. So it's a fast technology. You can print plastic parts, you can print metal parts, and again, it touches anywhere from the classroom. So, engineering students who are designing different products on the CAD software, you can then actually see your part the next hour that you just designed from your computer. It happens right in front of your eyes. And so then it's also happening in the food space. They're 3D printing food to aerospace parts. So this particular part, and Anthony will go into it more, but it actually is for Boeing's, Lockheed's, those type of companies, OEMs. So 3D printing is a great industry, and every one of you should get involved. We love it, but so yeah.
Very good. Anthony, let's go over to your role now with regards to the company and your experiences now. We actually visited last week and saw a number of the 3D printing units. And what do you actually call a 3D printing unit?
It's just a 3D printing machine. Like each of them have their own specific names that we've got to know, but in general, it's just a 3D printing machine.
Mm-hmm.
Yeah, there's from the desktop versions that you guys may see in your classroom to a larger production scale that we have in our facilities. It can range from just a couple inch build platform to as big as 3 feet by 3 feet by 3 feet, that big cube. So they range in size and they range in the process of what they can do.
And your role then in the process itself?
So I have a few different roles. I work kind of across different business units. Initially, I started as a design engineer, so I designed specific parts for prototyping as well as designs for traditional injection molding manufacturing. Also, I work in the R&D section, so I do research and development to develop new materials. So the materials that you guys may have in your classroom, we're working on making new ones, making it so that right now one of the weaknesses of 3D printing is that there's not a lot of materials available. So we're working on that. There's become so much awareness in the industry that they made it a point to decrease those weaknesses and try to make new materials, and that's something that I help with.
Okay.
Yeah.
Now we have a video clip here, if I can bring it up.
Yeah.
Okay, and we want to take a look here.
So this specific process is a metal printing process.
Well, let me.
Okay, yeah, I just want to give them a little
for
background first.
Whatever reason we're not, it's not coming up here. Let's see here. I'm not sure why that's not happening. Let's go over to bookmarks. Okay, here we go. Okay.
Is it showing?
Yeah, well, once I get it going here, yeah, I have to put on the thing. There we go. Okay, we're gonna start this over again so that you can hear it, and we want the music off then?
Off, yes, please.
Yeah, all right.
And if you want to make it full screen.
Yeah.
Yeah.
We'll do that.
So to give you guys a little background, you can print both in metal and in plastic. This specific instance that you guys are showing on the video, that's a metal 3D printing. Right there is just cycling through the different layers of the part. So it's actually physically how the part is being printed, layer by layer. There is for this process, there's a metal powder bed, and it's fused together with a laser. So that laser shines off a mirror and reflects onto the powder, which fuses those metal particles together. Then once each layer is built, that arm will go across and lay down a new layer of powder. Then that process is just repeated. Through all or most of the additive manufacturing processes, that's the idea. It prints layer by layer, no different in this case. This just particular process uses that layer to fuse together the metal particles, so that after each and every layer is built, you print through it successfully, and then at the top the part is finished. And then it'll show you here in a minute what the finished product looks like. So you can see you have a freedom of making essentially whatever geometry you want. And that's one of the biggest benefits of 3D printing, is that you have a freedom of design. You can design whatever you want, or mostly whatever you want to come out. That's opposed to the traditional manufacturing methods that you can't do that. So that's the one big benefit that always comes back to 3D printing. Why is it useful? Because you can do things that never have been done before.
Okay. Now, in this process, the prototyping, could you explain, maybe define for the kids actually what a prototype is, so they have a better understanding?
Yeah, so a prototype is just any part that you design in your CAD model that you can print. So for instance, this part here, like Dana said, it's an aerospace vent. So we designed this on our computer and sent it to one of the prototype machines, and it prints it layer by layer. So the machine directs where the material is being laid down. This case specifically, this is an FDM part. So these are the same type of parts that get printed on the MakerBot or those desk type printers that you guys may have at your school or maybe one of your friends have. And it lays it down layer by layer until the part's built completely. So this part specifically cannot be built in traditional manufacturing. This is what I was saying about the freedom of design and prototyping having that advantage over the traditional manufacturing methods that have been done before.
Now, Dana, you are involved in the marketing aspect of the company and the products. And Anthony, you're actually, again, an engineer involved with the, not necessarily the production, but at least the production of the prototype, okay? If these students are looking to get involved in this type of a career, okay, what would your suggestion be as far as certification and education?
So my suggestion is to do a lot of research. If you have access to engineering software and a 3D printer, work on it as much as you can. And ask your teachers a lot of questions on, different things you can learn about additive at a young age. Right now, a lot of the curriculums in colleges don't specifically have majors in additive manufacturing. But you don't have to go into engineering or additive manufacturing. You can go into marketing and do research like I did. I didn't have an engineering background. I didn't grow up with manufacturing. I had no idea what I was getting myself into, but I grew to love it and have a passion about how things are made. And this door handle couldn't have been made with traditional manufacturing. I don't know if you guys can see it. It's a seahorse, but it's highly detailed, made on a printer, and things like that are cool. So I would continue asking a lot of questions, doing a lot of research, and Anthony will have a different perspective. But for me, for marketing, as long as you have a little bit of background, you can grow to learn and understand the additive manufacturing world.
And what about that plastics engineering then? Is that what this is all about?
Yeah, so that's my background. So like I stated before, there's different processes, so there's metal and then there's ceramics as well you can print. So plastics just isn't the only 3D printing method, but that's how I got my transition into it. There's so many different avenues that you can go down to get into 3D printing. The one thing that we always say at our company, it's kind of like, it's like we're a land of misfits. So there's so many different backgrounds that everybody has, and everybody came together to form our company. So saying that, there's just a lot of different avenues that you can go down to get into it, whether it be in engineering, a marketing, a business. The industry is so new that no matter which way you can go down, you can still get into the industry.
Okay, very good. Well, we want to start taking some questions here so that our kids have an understanding, maybe a better understanding, and again, provide us with some direction for us. So we want to open up our microphones right now and give you an opportunity to ask some questions. So we're going to start with Rocky River, and we'll go to C-Tech, and then we'll go to Hillsboro, and then to Vermilion High School. Those will be the first four. So students, please make sure you're close to a microphone. We'd like you to introduce yourself with your first name, ask your question, and then please put your microphone back on mute. That will keep your sight on our monitor as Dana or Anthony respond to you. So Rocky River, do you have a question for us, please?
Hi, my name's Anna, and I was wondering how 3D printers will change in 5 years.
Good question, Anthony.
Very good question. Yeah, so thank you, Anna, for your question. The reason how 3D printers are changing in 5 years is because so to give you a background, 3D printing has been around for 20, 30, 35 years or so, and it hasn't changed a ton. So there's been a lot of advancements in the past 5 years or so, but not a ton over its lifetime. Right now, there's so much awareness of the industry that everyone is trying to get in. They see the weaknesses and they see what it can do, and they're trying to improve upon those. So a few things just off the top of my head that can change are the advancement in materials, which is a weakness currently, the speed, which is kind of a weakness currently, as well as the size. So when anything advances, they want to go a lot bigger. So like, how big of a part can you print and how small can you print? Those are the two areas that they want to advance. So in short, it's going to be the materials going to advance, the speed of the printers, and as well as the size of the parts are all going to advance.
With regards to size and how big of a piece can be printed today?
Well, there's several machines that have been, they're 3D printers, but they can print like small houses that have been printed. So they use like cement to print it, and they use that as well. So not the plastic or the metal, but like cement to print it, yeah.
Okay.
And those can range up to be about 20 feet in size, I saw in one instance. So they can be pretty big.
And going back to some smaller objects, just from what Togus does, the kids aren't maybe not be aware of this, but they actually produce the Vitamix mixers, blenders.
Yeah, that's correct.
And also that ever-ready yellow battery flashlight.
Yeah.
If I'm not mistaken. Anything else that's common?
There's several parts that, so here's, I'm sorry.
The knee.
Oh yeah. Here's a knee prototype. So whenever someone gets a knee replacement, the doctor would take an MRI, take a picture of their knee, and then they can go back and print this specific one so that it fits them perfectly. This is another advancement that's going to happen. Everything's going to be personalized so that there won't be as many errors in surgery because they have something to test against, to practice on, as well as whenever someone gets something printed, it's personalized so that it's less chance of a part maybe getting rejected by their body.
Good question, Rock River. Thank you very much. Let's go to C-Tech and then to Hillsboro, Vermilion, and then to Orange. C-Tech, a question for us?
Okay.
What brand of 3D printer machines do you have, and what are the limitations on that specific printer?
Go ahead.
So for FDM alone, so those desktop printers you have for that same process, we have what's called Stratasys machines. So we have the one size machine is called a Fortis 400. That prints parts that are probably a little bigger than this, so 16 inches by 14 inches by 16 inches tall. That's the build envelope of that one. And then the larger scale machine, which is the largest production scale on the market, it's called a Fortis 900, and that prints parts that can be 3 feet long by 2 feet wide by 3 feet tall. So you can print a very large part in that. We actually have a few of our tables that we print, that we showcase parts, like the size of this table we're sitting at here. We printed it, and that way we can showcase parts on top of a part we actually printed. So it's pretty neat.
Thank you, C-Tech. Let's move on to Hillsboro, and then we'll hit Vermilion, and then Orange, and then to Cheney Youngstown. Hillsboro?
Hi, my name is Austin. I was wondering, what do companies like Shapeways say for the future of 3D printing?
Yeah, I think I can't speak on behalf of Shapeways, but from what our knowledge base is, I think they want to customize anything and everything. So whether it's jewelry or different art pieces, I mean, they say that it's just going to keep growing. There's going to be more custom pieces, again, more on the art side, I would say, of it.
And the custom aspect, of course, is in a sense the personal aspect.
Correct.
As Anthony mentioned about the knee replacement. Okay?
Yeah.
As individuals need specific items, specific pieces of equipment, a knee replacement, toe replacement, and/or whatever.
The chair, like different furniture, if you guys can see this.
Here, we can zoom in on that. Hold on one second.
Can basically make, custom art furniture pieces and jewelry. I should have worn my bracelet. I have a 3D printed bracelet.
Good question, Hillsborough. Thank you. Let's move on to Vermilion now, and then to Orange and Cheney, and then to Beechwood Middle School. Vermilion, a question for us? All right, let's move on to Orange, and then Cheney, Beechwood, and then La Plata in Maryland. Orange High School?
Hi, my name's Eben. I was wondering how complex of a thing have you printed, or how complex could you print?
Why don't we show them that?
Oh yeah, that's a good. So you can print parts that are extremely complex to something as simple as this moving device where it's all printed in one piece, but whenever you set it down, you can move it and they all interact together to be able to print together and work together. This is kind of like a simple, novel type of item, but as well as you can print parts like this. This piece here is for a turbine, and you wouldn't be able to make this any other way other than 3D printing because of the curved surfaces. Sorry, you can't really see that. But this is a pretty complex part that, like I said, can't be done any other way, and the wall thicknesses are extremely thin, so it's very difficult, even if you could do something like it, to replicate it any other way.
Okay, and those are actually moving parts that once that piece comes off the printer,
Yeah.
They're moving already.
Well, with a case like that, it would be surrounded in what's called support material. So parts that have overhang. So if a part like this is printed and it's upside down, there's going to be support material that encompasses any overhang areas, so it can print without printing on air, and then it would start to droop. So that case specifically, you would need to take the support material off, which can be done pretty quickly in most cases, and then it'd be moving.
Okay,
Yeah.
super. Thank you, Orange. Let's move on to Cheney High School, and then to Beechwood, and then to La Plata High School. Cheney, question for us.
Yeah, okay. We have two questions, actually. My name is Josh. You mentioned 3D printing food. Can you tell us a little bit about that?
Oh, well, so 3D printing food, they've made pizzas before. They're customizing chocolates, so hopefully, the chocolate stores pick them up in stores, so you can go in and print out, it's melted chocolate and then cools pretty quickly. So you could do any shape, whether it's a heart or your name. So that's kind of what we're seeing right now. And they've also 3D printed food for astronauts who are going up into space. So they're taking 3D printers up with them, so they have food on demand.
Thank you, Cheney.
Our second question.
Okay, go ahead. We're going to give it. We're going to come back anyway, but go on. We'll take your second question.
My name is Jamon, and you guys were talking about plastic engineering. Is it like chemical or mechanical? Like, what type of engineering does it deal with?
Okay, that's a good question. So plastics engineering specifically it's kind of a hybrid. So in my curriculum, there was classes similar to mechanical engineering, similar to chemical engineering, and a lot of just base general knowledge that just the engineering programs do have. So it's kind of a mixture. And whenever I was in classes, we started off their engineering specific classes very early in the program. So it's something different also than the general mechanical or chemical engineers.
Let's go back to the printing of candy. Okay, that has to be very costly, would it not be?
I'm not even sure how much those printers cost. I don't think it'd be too much though, because you're really all you're really doing is you have melted chocolate. It's already mixed. You put it in the chamber or something, and then it just it's heated like a hot tip, and then it extruded similar to like a hot glue gun, and then it lays on a bed that's cool, so it hardens pretty quickly. So I can't imagine it being too costly.
Okay. But again, that would be customized, though.
Customized, yep. Yeah.
Okay.
Because you can throw out candy kisses off the machine a lot quicker than you can.
Chocolate on demand.
There you go, exactly. Okay. Thank you, Cheney. Let's go to Beechwood Middle School, and then to La Plata, and then we'll go back to Rocky River. Beechwood, question for us, please.
My name's Mitchell from Beechwood High School, and I was wondering what's the biggest industry for 3D printing?
Good question. Go ahead.
Thanks, Mitchell. So right now, 3D printing is entering in so many different industries. What I would say the biggest is what typically is the biggest whenever any big movement starts. So whenever advancements are made, it's typically like the aerospace companies. So we're working a lot with aerospace companies to do that development. I would say that's the biggest right now. Mm-hmm. They're doing that legwork to advance the materials, advance the processes, and we're assisting them so that it can take 3D printing to the next step, to the next level, so that it can be not replacing traditional manufacturing, but complementing it even more.
Thank you, Beechwood. Let's go over to La Plata High School in Maryland now. La Plata, question for us.
Hi, my name is Mark, and I was wondering, in this slow economy, what is the outlook for employment within your company?
Can you repeat that question, please?
What is the outlook for employment within your company?
Outlook for employment.
Outlook for employment within your company. Okay.
So as we grow, we're going to constantly be hiring, and especially this industry is growing so quickly. Currently, we always take applications. We always are open to answering any questions, students or anyone who's looking for any opportunity. We're always willing to talk with you. So I don't know if we're exactly hiring on right now, but the industry is growing so fast that I can imagine we're going to probably be adding 40 people within the next year. So definitely contact us, reach out to us. We have internship opportunities and see what's available.
Well, let's go back to RPM plus M and Togus and talk about the opportunities that are there right now, because you are just two of the employees, okay? Mm-hmm. And there are a variety of other employees there. And when we were out there visiting, we also talked about the possibility that high school kids, there are some opportunities for them to get their feet wet. Can we expand upon that, Anthony?
Yeah, so we have several people additional to Dane and I that started off as interns that turned into full-time positions. There's also several cases which people that had, they're working during whenever they were in high school, like half days, started to work, and then they turned that into full-time as well. So one of my colleagues right now, he's currently taking classes in college. He just graduated high school 2 years ago, taking classes at night and working full-time. And he started out whenever he was 16 doing and working as an internship.
So those opportunities are there. Yeah. What are some of the other positions now on the floor with regards to the company itself?
So with RP&M, the handwork, getting really involved in the 3D printing process, there's several finishing positions. So whenever the parts come off, they're not perfect. They're not exactly what you may want. So we need to finish them. So secondary processes to maybe smooth out a few surfaces, take support off, do things like that. There are also positions to help prepare the print. So getting the machine all ready, doing maintenance on it, as well as sending parts from the computer to the machine. Those are just a few positions that are available.
Okay. If students today were interested in getting involved in this advanced or additive prototype manufacturing, what do you think? What courses should they be studying now in high school in preparation for college?
There's a number of classes you can. Whenever I was in high school, I did the physics, calculus, the chemistry. Those were just a few base classes. In college, I would say whenever you take the engineering route, that they set your curriculum, so they would set the route for you. But any additional chemistry classes are important, in my opinion, as well as any mechanical engineering, so like the strength of materials and maybe a thermodynamics course. That could be a good positive for courses to take.
And Dana, now that you're in marketing, what would you suggest that kids who may have that thought in mind for a career in high school, what type of courses should they be involved with?
Honestly, anything. I think that if there's any creative writing classes, I think that would be great. And if you don't necessarily want to take the chemistry or the math classes, that's okay, as long as you keep reading and writing and your willingness to learn about the technology, ask questions about it, you pretty much can take any classes for the marketing and communications realm.
Yeah, I think that's honestly, you could take any class, and as long as you transition like the passion for 3D printing to whatever you're doing, it doesn't matter what specific classes you're taking. You still have to be aware of everything that's going on, doing additional research besides the classes to really like excel in this industry. Yeah.
Okay. Let's go back for a couple more questions here. Rocky River, let's come back to you, and C-Tech in Hillsboro. Rocky River?
Hi, my name is Max, and I was wondering how long it usually takes to print things with the 3D printers.
Good question.
Thanks, Max. It depends on process and depends on complexity of part. So just right here, this part, approximately 6 inches tall. I bet this took about 4 or 5 hours to make, something like that. So it's not extremely fast, but it's faster than if you would need this part and you didn't have 3D printing. So you would need, first of all, to modify the geometry. Second of all, to get a mold made, which could take 6 up to 10 to 12 weeks. So you're at 1 day part in hand versus 6 to 10 weeks, so a couple months. This door handle part is actually, this is about 3 pounds. This is the most expensive door handle ever made. And I bet this part took, the metal processes are a little longer. I bet this part would take approximately, let's say 20 hours, so maybe around a day to print.
Good question. Thank you, Rock River. Let's go to C-Tech in Hillsboro, and then see if we can get back to Orange. We've got about 6 or 7 minutes here. C-Tech, another question for us.
Yes. My name's Cole. I was wondering if Organovo and organ printing companies are involved with the 3D printing field.
Yeah, I would say they're definitely getting involved. Right now, the only official medical printing that's going on is just for prototype use, not for really functional use. So this part right here, like the metal processes, they have more of a chance to be functional. But right now, for instance, we printed a skull. So there was a patient that had head trauma, so they fractured their skull, and then a doctor took the MRI, sent us the part, we printed it out so they could practice their surgery and see what it actually looks like before they went into surgery. So it assists the doctors extremely. So taking it to the organ stuff, they're advancing that right now, but it's not completely functional right now. I would say that it could be there in 5 years, but it's hard to say.
Thank you, C-Tech. Let's go to Hillsboro now for another question. Hillsboro?
Yes, hello. My name's Mauricio. What method do you see being used to mass produce plastic products that can't be made by traditional methods most efficiently?
Can you
repeat the question, please?
Sorry.
So, what methods do you see being used to mass produce plastic products that can't be made by traditional methods?
Currently, what we're doing is we're using the FDM technology. So our company started off as a prototyping strictly company, and it's grown into the low volume production. So we're printing parts off the machines that are going, that are production parts. They're being tested right now to go into airplanes. So right now, with the build platforms and the materials that are being developed and offered on the fused deposition modeling technology, I see that as the main technology for production that you wouldn't necessarily be able to use for injection molding or the traditional ways of manufacturing.
Okay, we've got a couple more minutes here. Let's talk about the design contest.
Mm-hmm.
Okay.
Yeah, so this was started, we're now in our 2nd annual design contest, and what we do is we invited the schools in our surrounding area, just west of Cleveland, to participate in this contest, which they, in their engineering classes, they design different parts. So each year there's been a specific category. So for instance, this year it's assistive technology, for anything that would be assistive to any like type of handicap. If someone has a handicap or an injury or anything like that, that you can 3D print. So what they do is in their engineering classrooms, they come up with ideas, they brainstorm, think of specific things they can design for additive manufacturing and print, and then they send them to us. And in the contest, each school has their own week in which we print their parts for the one full week, and we print them on our own machines, the production full scale machines. And during that week, they would come in for a tour. We would show them their parts printing. We would show them how a 3D printing facility works, and all the different technologies that we have, as well as during that time they present their ideas to us. Present their ideas to a panel of judges that they judge the ideas, and then once all the schools are complete, we pick one winner that receives a MakerBot printer for 1 year. So the first year was very successful. This year we're up to, I believe, 8 schools now, and hoping for another great year.
Okay, let me put some contact information up for you. Both Dana and Anthony are willing to share their contact information, so we're going to put this up for you, and you're more than welcome to contact them if you'd like. I need to go over to my other camera here. And let's just put this up as a slideshow from the beginning, and then there you go. So there's their contact information. If you are interested in learning anything else about the business itself, and also, Anthony, are we already set for schools for this year with regards to this contest, or can other schools apply?
Other schools can definitely apply. Yeah, we're still open. I haven't finalized the schedule yet. Hoping to do that by hopefully in the middle of January, about then. So
okay. We have a couple out-of-state schools. Is there any way that they could possibly participate via and maybe doing via video conferencing?
Yeah, that could definitely be a possibility. They could still send their parts and we can ship them back. I think the tour would be a little more difficult, but we'd definitely consider that. Yeah.
We can put a video camera on your back. And,
definitely. There we go.
Yeah.
Technology. Technology is best.
Yeah.
So just keep that in mind. Well, we are again just about out of time, and I want to thank both Dana and Anthony for being with us this morning. This is a new direction now in manufacturing. As we said at the beginning of the program, the old dirty foundry is still around because there's a need for it, but for the most part, very, very limited with regards to what they do. Today, everything is in advanced or high-tech technology. The opportunities are there for you as new workers, whether you're coming out of high school with just that diploma, or with an associate degree from a community college, or that 4-year degree. There are tremendous opportunities in manufacturing. And of course, here in Ohio, Ohio's in one of the top 5 states in the country in manufacturing, so the opportunities are there. So again, thank you so much for joining us this morning, and hopefully we will see you again before the end of the year. Thank you.
Thank you.
Thanks, guys.